In this video, I want to show you how the project tree works in OIM Analysis and how we can create different maps, charts, and plots and evaluate their properties. So if I open a data set here, I'm going to choose one that's aluminum film. It'll of course load the data, give us our summary view of the statistics of this particular scan. But what I want to emphasize here is the creation of this project tree. So on the partition or the project, the top level is what we call our data set level. And underneath this, we have what we call our partition levels. And the default partition is the all data partition, which contains all the data. So from here, as we saw in an earlier video, we could create a image inverse pole figure map or an image quality map that populates that particular partition. If we want to create things manually though, I can right click on here and say new, and this is where I can select a map, a plot, a chart, or create a texture. So I'm going to show map here, and when it does this, it loads the properties for an individual map, and from this we can select the type of grayscale map we want. So these are the different types of grayscale images we could select. So different imaging scalar values, Prius images, things on grain size, grain shape, misorientation. And then I could select a color-coded map. So if I wanted to select an IPF orientation map, I could come down here and say IPF. For either of these options, you'll see that we can select the edit to bring up the details that are being selected. So for the image quality, you'll see our grayscale range is set from 0 to 100 in terms of the percentage. So the minimum value is 0, the maximum is 72.75. Also gives us an average. So the minimum will be colored black, the maximum will be white, and everything will be shaded between those. If I wanted to adjust the contrast, I could either hit the ACB button for an auto contrast brightness, or adjust either the percentage values or the absolute values. Same thing for the inverse pole figure. I can look at the edit button here. In this case, it's showing the reference vector used to define the sample reference frame that we're displaying the orientation. So in this case, we're looking at the A3 axis here. The axis that's pointing out of the surface is 1, and the axis 1 and axis 2 are both 0, 0. So that means we're looking at the surface normal orientation. And we're going to show the crystal direction parallel to this sample direction. So I'm going to hit OK here. And if I wanted to add a boundary, you can see I have a number of different boundary types. I'll just do a rotation angle. I'll add everything greater than 15 degrees, and I'll make it a black line here, and I will hit OK. And there it's drawn the map. The details here have been defined. For any map or any entity in here, I can come back and say right click on the properties and bring that back up again. And that allows me to come and adjust these if I wanted to add. And let's say I didn't want it to be the surface normal, I wanted it to be the A1 axis that we're going to shade the orientations to, then the colors will change. And you can see that it has automatically populated the file name here, but I could give it my own name, as in OIM IQ IPF training. And then when I hit OK, it'll keep that map name there. Now, I mentioned before we created this all data partition. If I open another data set, this one I'm going to load a multi-phase sample. So you'll see here in our summary view, we have an austenite, a sigma, and a ferrite phase. So when it has pre-populated the project tree, we see we still have the all data, but we also have the austenite, the sigma, and ferrite partition. So basically each phase is defined as a partition. So I can come in here and say, click on my all data, show me my image quality map, show me my phase map. Again, if I wanted to make and add my image quality and phase map together, I could right click on the properties, come here and select image quality, and get a map that looks something like that. Now, if I'm looking at my orientation map, the thing I want to point out is with an orientation map, you'll see here that, I'll put this so we can see all three, austenite and ferrite are both cubic. Austenite is face-centered cubic, ferrite is body-centered cubic. sigma is not cubic. So this coloring will change from one phase to the other. So the blue color would represent a 111 orientation for austenite and ferrite, and it would represent a 110 orientation for the sigma phase. Obviously that makes interpretation a little different. So what we could do is we can look at the orientation of each phase by selecting the phase and creating our orientation map for each one. Now, because the austenite and ferrite are both cubic, we could use the same triangle, and that's where we can create a partition. So I'm going to right click here and say a new partition. I'm right clicking on the dataset name, partition. And what I would be interested in saying is I am interested in defining things by phase. And I want to point out this is a point property, and I'll show you why this is important. Because I can select phase, and I say I want my phase to be austenite. This is where you have to be careful. I don't want to hit and, because I don't want my point to be austenite and ferrite, because no point will have that. So it'd be austenite or phase is equal to ferrite. And then this will create a new partition here, and I can look at the orientation of that. And if I compare this again and I just look at my phase map here, you'll see that those are where the austenite and ferrite grain's been defined. The black areas are the sigma phase that's been excluded in this partition. Where if I come to my all data and look at the third map here, we can see that the sigma is the area that's now black. So this shows how we can navigate via the project tree. We can create maps, we can create partitions. Everything in OIM analysis is driven by a right mouse click. So all these things we can come back into. We can identify the properties, come back into here. We can also do things like export, cleanup, copy, delete. Those things you should explore to see the things that are possible from all these things with a right click. But it gives an idea how the data is organized into a project and can be saved as a project as well.